I want to welcome everybody for coming. Those on Zoom, we have many more people on Zoom than in person, which we anticipated a little bit. And I thank all of you for coming. There's plenty of food, so obviously you should feel free to get up and get as much you want as the talk unfolds. My name is Mike Borgstrom. I'm the director for the Center for Teaching and Learning and professor of English and Comparative Literature here on campus. And this event really arose as a kind of organic collaboration between CTL and the Digital Humanities Initiative, which is run by my colleague Pam Lack. And we, many avenues on campus right now are trying to respond to this widespread interest in artificial intelligence. And as I said at an event earlier this semester with my colleague Sean Howes, who is director for ITS, it's very interesting and sort of gratifying that the response has been not one of panic, but one of curiosity. At least that's what we're hearing primarily. I think there is a little bit of panic, but it's not widespread. When Pam and I started talking about these issues, our colleague Amanda Simons, who is in Linguistics and Asian and Middle Eastern Languages, that's the title of a department I always have to look down to make sure I get correct, really sort of instigated the conversation. And we are really pleased that she's agreed to moderate the conversation. And we're very grateful for her expertise and for her engagement. So I am going to turn everything over to Amanda and turn off my microphone so I can gobble some pizza as well. Amanda, thank you.
Thank you so much, Mike, for that introduction. My name will read Gabriel Doyle at the bottom, but my name is Amanda Simons, since Gabe will be taking over here soon. I do want to point out for the folks in the room, and I'll remind you again later, if speaking, please speak into the mic for accessibility for Zoom users. And for everyone, please use the shared written spaces freely. In Zoom, that'll be the chat. And then in person, you've got the tables with the whiteboard markers. So I do appreciate Mike giving a little bit of an overview of what our goal is with this learning community. And as we were in the initial talks, I wrote down one of the things that we came up with was come with questions, leave with more. And, you know, kind of along the lines of we have lots of questions and there might not be answers. So, but we are hoping to explore it, just because I think that right now, some of the common ways that people are learning and coming to understand ChatGPT are seeing the writing it has produced, kind of playing with it themselves, and of course, hype articles with lots of different takes and experiences with it. So our learning community goal, I think, is really to look at the larger context by zooming in, turning over crucial details and exploring them, and then also zooming out by looking at the bigger picture, what its impacts are, things like that. And today, the way that manifests is we'll be looking at some of the inner workings of these systems, looking at how are they producing this language so fluently. And then also some of the nearly inevitable consequences of these systems and how they end up having these untruthiness, and how we can, and how us humans sometimes respond to this writing, this language that seems so human-like. So I am really excited for these conversations. We do plan to have more of these sessions. We hope that you'll join us. We hope that you'll bring your questions. And if you have answers, that's great, because that's certainly something that we're looking for in this space, but probably just having conversations. So I'm really grateful everyone's here. I do want to introduce our presenter today, Dr. Gabe Doyle, who is an assistant professor in the Department of Linguistics and Asian and Middle Eastern Languages. Mike, I also have to sometimes look, even though that's my department. He's a computational psycholinguist, meaning that he's really looking at the interactions between languages, computers, mind, psychology, society, and sort of how they interact with each other, how they play off each other, how they affect each other. He has been working with AI for 15 years, so this isn't his first rodeo, but the rodeo has certainly accelerated and manifested in some new and interesting ways. So thank you so much for being here, and I will be handing it over to my colleague Gabe, after which we'll have some small group discussions and a larger discussion, and hopefully come away with some good ideas about this topic. Thank you.
Okay, hey everybody. Let me go ahead and start sharing my screen and then also my slides. I just have to wait for the Zoom thing at the top to go away so I can hit the button. Okay, it's not going to. There we go. All right, so great. Yeah, that's everything. Well, thanks everybody for the introduction. I should really confess here, when I was putting this together, even just in the last weekend, I got an email from Mark Gavrin, one of the other professors in our department, with a New York Times article that came out. It was most recently updated on the 17th. And I took out a bunch of stuff that I was going to write in this talk, just because it filled me with a whole bunch of other ideas about what we should be talking about. This is a really big open area. And I'll be honest, I'm frustrated with just how much is going on that I never feel like I can get my feet set. So with this talk, I'm going to try to do my best to bring up some of the things that I know that I think, have helped me kind of think through what's going on with this. But yeah, I'll apologize straight off the bat that I don't know how much I'm really adding. I think a lot of it is going to be the things that develop from our conversations. So since I also had a lot of stuff to try to jam into this, let me go ahead and just get this started. Try to slide my way out of here. Well, whatever. All right, so the first thing is that while this has been a really big thing over the last 2, maybe 3 years that OpenAI and the really big large-scale language models have gotten talked about, I think one thing that's really important to keep in mind is that they are extensions of something that already existed. Language models, the underlying representation of what language is that powers these AI systems, aren't something new. And I, of course, chose 2 fairly new examples with things like how your phone does auto-completion and auto-correction, or how voice-activated digital assistants work. All of these are based on the idea of trying to build a good model of what language is. But this goes back even further. So there we go. Here's kind of a quick example of how these sorts of language models end up interacting with bigger, kind of bigger interfaces, bigger frameworks. So this is an example from kind of basic speech recognition. And I chose an example, I forgot to put the link to the citation here, but this is from an adaptation of something from a psycholinguistics study from Yurovsky et al. 2017, looking at how kids understand language. But we can also talk about it in terms of how computers handle this. So the basic idea here, if you think about what's going on when your phone is trying to transcribe your speech, or you're dictating to a computer or anything like that, well, underlyingly, there's 2 different interacting models. One is the acoustic model. That's what I've got over here on the left. And so we've got this waveform coming in, the actual vibrations of the speech that you're producing, hitting the microphone, and being conveyed to the computer. And in a lot of cases, when we speak, we don't say exactly what we mean to say. So for instance, in this example, I'm trying to say, I ate peas and carrots last night, but I don't articulate it very well. I end up voicing the first sound in this word. And so it might be something where I meant to say, I ate peas and carrots with a P sound, but instead it comes out as I ate bees and carrots. And the acoustic model says, well, I've scored this up and I think the best fit is that you said you ate bees and carrots. But of course, we want our speech recognition system to sort of say, okay, I know it might sound like that, but that can't be what he actually meant to say. So we couple it with one of these language models. This example that I'm showing here is something that I took from Google Books Ngrams. This kind of was one of the very large language model data sources that was used for a good long while. And here you can see that saying that somebody ate peas is much, much more common, although as it turns out, not the only thing, but much more common than eating bees. And I even tried looking at specifically the peas and carrots and bees and carrots, and it turns out that there's no instances of people talking about bees and carrots in this data set. So the language model says, well, the acoustics might have been messy, and it might sound like this guy was eating bees, but that's so unlikely based on how people talk and what people talk about, that essentially the score for something like peas and carrots is so much higher than bees and carrots that we can overrule it. And so these two feed into our computational system, and it ends up saying, okay, I can confidently say that you said peas, or at least that you meant to say peas. So these are some of the ways that these language models have already been lurking around. It's just that in recent years, they've gotten good enough to kind of stand on their own and be something that we can actually start to look in and see, what they're doing behind the scenes. Next, I wanted to talk about kind of a brief history of this. For those of you who are older and more experienced with these sorts of things, or like me, grew up on the internet and had a lot of chances to talk to really dumb early chatbots. One of the classic ones, probably the first real chatbot in the way we would think of these, is ELIZA. It was developed in 1966 by Joseph Weizenbaum. And he was intentionally designing it to show the superficiality of human-computer interactions. It worked through pattern recognition. Basically, there were a set of things that it knew you could be trying to convey information with. So you can see a couple of the examples here. Aren't you some sort of frame like that? ELIZA can recognize and say, okay, you're talking about me. Well, now I can turn it around on you with these scripted responses. If you say, aren't you? ELIZA says back, you're not really talking about me, are you? And encourages you to lead the conversation. By doing things like shifting the effort, the conversational momentum back onto the human, this system that's really, really simple can be kind of passively carrying on a conversation. You can see by the end of this little bit here, after the person in frustration just kind of stops communicating, when they jump back in with what is elucidate, what do you think? Oh, to see, oh, could you elaborate on that? And eventually we're, as the human, doing the work on this. Now, one interesting thing about this is that while ELIZA was designed to show this sort of superficiality, Weizenbaum found that people who interacted with it would engage with it and have kind of empathy, feelings towards it as if it was human, even if they knew that it was a computer, even if they knew how it worked. And this is something that sometimes gets called the ELIZA effect. And I bring that up because if in 1966, this sort of scripted response is enough to get us thinking, oh, but maybe it's human, or maybe it's human-like, we should be really aware of this as things have progressed and we get these new systems, to stop ourselves from thinking that way, that we have this bias towards believing that anything that is producing language, this most human of things, must be human-like, and this can lead us astray. Okay, I'm just going to jump through this very quickly. I kind of wanted to toss this history on there, even though I knew I wouldn't be able to properly get to it. Over the years, this sort of system has improved. Throughout the 90s and 2000s, one of the big things was Ngram-based models. These are based on word strings. If I know the last two words you've said, what do I think the third word will be? And the big advantage of this is that they're easy to train, calculate, and interpret, and they do a pretty decent job of approximating a lot of human things, including some psycholinguistic measures, things like reading times, for instance. People read words slower or faster based on how predictable they are based on the two preceding words. But these also have a lot of disadvantages. We miss out on a lot of long distance connections between them. As humans, we build these hierarchical structures, this tree structure that I've illustrated here. Our sentences connect over long distances, and our discourses connect across sentences. The disadvantage of something like these n-gram models is that they don't know these long distance connections. They're limited to just the couple of things that we've recently seen. And so one thing you'll find with language models based on n-grams is that they constantly lose their train of thought. They will start talking about something and kind of diverge off onto, something that sounds good for the recent couple of words, but doesn't fit with the start of the sentence. So what we have now, this new generation, is something that's known as deep learning and specifically as transformer models. And deep learning, as with a lot of things in AI, it is a sort of branding. There's a sense in which deep learning sounds very good, and so that name's stuck. But one thing also to keep in mind with this is that deep is referring to the model's structure, not to the depth of thoughts. With something like these pattern and script systems or n-gram systems, we have very, very simplistic, shallow interpretations of the language. On the other hand, with something like deep learners, we have a multi-level representation. It doesn't mean that the representation is, again, conceptually deep or even necessarily like humans, but rather that increases in computational power have allowed for a more complex representation to allow the computer to do more stuff, basically. So here's the basic structure of the deep learner. I'll move myself out of the way again a bit. And if this is something that you have not seen before, don't worry, we don't need to go into it very deeply. The key point here is that what a deep learner is trying to do is move from some input to some output. Using something like an n-gram system, most of these use what are called skipgrams. We don't need to worry about the details on that. But basically, by looking at input of the preceding words or the words that are nearby in context, it's trying to learn output. What word should fill in the blank? Repeated training based on input and output. It's set up so that it knows in the training what is good input and what is good output. And then it uses these hidden layers, these lighter green ones in the middle, to try to build an effective connection, to say whatever information you're sending in the input layer, transform it through these hidden layers and send it to an output layer. The representation within these hidden layers is not intended and generally is not easily interpretable for humans. The power of the deep learner is that the computer is able to build structures that are useful to the computer rather than necessarily things that are useful to us. And again, that's a big change from these scripted systems and these n-gram systems. The power of these deep learners comes from having incredibly large hidden layers. So GPT, I forget which version of this was based on, whether it was 2 or 3, but it has 12 hidden layers with 3,000 nodes each. So essentially it's representing its language knowledge as a 36,000 dimensional space. Oh, yeah, and there was one other thing that I wanted to say on this, which is that this sort of training system, in addition to the fact that it's developing a structure that's intended to help it and be interpretable to it, not interpretable to us, its whole goal is to maximize its score. Whatever objective function we decide is the key thing that we want it to do, its whole goal is to make us happy with this. And so, for instance, if we want to decrease inaccuracies between input and output layer, it will do whatever it can come up with in order to achieve that goal. So that leads us to the big question. Well, what do these AI writers think that they're doing? And I'll put thinking quotes here because, again, they're not thinking in any way that we would think of it. At its core, what they're trying to do is maximize the evaluation metric that you use. And we won't have time to go into it, but this is going to be, I think, one of the most important things for us to think about today is what's a good evaluation metric? What kind of unforeseen consequences are there? What sort of foreseen consequences are there to the evaluations we have? How do we set up a task so that we're actually getting the computer to do the thing that we want rather than the thing that it thinks we want? Yeah, I'm going to skip through the rest of that because, again, made some quick changes. One thing that I think may help here is to think through some analogies for how these AIs are thinking. And the three that I've come up with are to think of them as improv actors. You ask them a question. It's like shouting out from the audience, hey, you're in a train station and you're wearing a hat, go. And it's going to try to come up with something that's internally coherent and satisfying to you, the audience. Who cares if it's nonsense? If you're satisfied, if you had a good time coming to this show, it's done its job. You could also think of it as like a kid telling a story. It'll keep going until it's told it can stop, in the same way that a kid might be like, and then I saw this, and then I saw this, and then I saw this, and this happened, and you're like, okay, that's a great story. Thank you. Please move on. Computers can be doing the same thing. If you tell it to keep going, if you tell it to try its best to answer the question, it'll keep going until you tell it, okay, good enough, thanks. And the last example, most maybe relevant to our group, is thinking of students taking a test, especially like a standardized test. You're using heuristics at times. You're trying to think of what the question would want you to say, and always make sure you give something. Even if you don't know, express certainty. There's no benefit to sitting there, especially on a standardized test, going, well, I'm not sure, but I think B. Just say B, and so it goes. I should probably skip over this part. I think we've sort of covered it. I'll try to share my slides out as well. So I put in a little extra stuff that I kind of knew we wouldn't get to, talking about kind of how humans and AI analyze these sorts of things and how they approach answering questions. But this is one of the things we can kind of discuss, in the little groups. The last thing I wanted to wrap up with, and this is some of the more recent stuff, is that larger language models for a long time were thought to be the key solution. Most of our limitations in early work was that we were working with computers in the 60s, in the 90s, in the 2000s. We could only get a little bit of data in there. People figured, well, once we get the whole world's data in, everything becomes easy, right? Well, there's been a lot of work from a variety of language model programmers. This is an example from a paper, it's linked here, from Perez et al. 2020. And this is an example where they looked at, as they made the model trained on more data and having more hidden layers, how did it do? And this particular chart is really interesting. They found that as the number of parameters grew, as the number of nodes in the hidden layers grew, sycophancy increased. That is to say that the more the language model could theoretically represent what it was talking about accurately, the more it would answer questions the way you wanted it to. If you ask it, hey, what do you think about this issue? It would say, essentially, well, I think you want me to say this. It's gaming the system. And that's our big problem to think about here. Again, getting back to this issue of what are you trying to optimize? So a couple of big problems that show up here, in addition to things like sycophancy, kind of repeating back to you what you have already said, we also have to deal with things like hallucinated facts, confident statements of facts that were created just because they fit together into a good sequence. When did the Civil War start? I don't know, you clearly want a date here. I don't know what it is, 1715, let's say. That sounds good. I'll say it as if I know what I'm talking about, even though I'm just an AI that said, you wanted a date and I didn't know. And one of the other ones from this Perez et al. Paper is this notion of myopia, that it has a preference for short-term problem-focused gain over long-term general goals. Okay, this sets up a need for guardrails. And again, I'll be honest, I don't really know what the right kind of guardrails are. And that's why I'm hoping to, chat about this. And this is where I would put a conclusion slide if I felt like I had a single conclusion off of this, but I don't. So what do we do? Let's talk about that today. We've got a couple of kind of potential questions to seed a conversation. We've been talking a little bit about the inner workings and some of the things that come out of that, some of the unintended consequences. How does that change what you're thinking about these systems? And how is this crucially different from the sort of writing process and thinking process that our students behave with and that we want them to behave with? So what kind of things can we do in classes, in talking about this, in working through the reasoning to kind of undermine the point of seeking out AI? Well, maybe seeking out useful AI help, but not bad AI help. And then I guess I'm kind of stepping on Amanda's line here because I'm not in charge of future sessions, but also what else would we like to look at in future sessions? Don't mind. But yeah, I think that that's everything on my end. I'll turn it back to Amanda.
Thank you so much, Gabe. So we do have some time. We set aside that there would be, if anyone had any pressing questions about what Gabe said, you'd have an opportunity to ask, either if you're on Zoom or in person. And remember, if you're in person, raise your hand. We'll make sure that a mic comes to you so that way the people in Zoom can hear. So I wanted to check. And Pam, is there anyone on Zoom? Okay, great. Hold on just a minute.
Yeah. More of a curiosity thing than a pressing change my life question, but
Yeah.
I'm curious. When I record all my lectures, which I all online now and teaching, and I do it through Zoom now. I've been through several systems. I'm very flexible. But which type of system do they use for translation in the recording of those? Because I'm curious. I get very odd things like, we'll have the pink bananas or something.
Yeah.
That's not what I said.
Yeah, so, I mean, I don't know about the specific implementation, but it's the same sort of idea where it's bringing in what it's picking up from the acoustics.
Speaking of that,
Yeah,
that side of it doesn't seem to have the other. And she's reminding me that I asked the question, now I'm still talking, is that it seems to be on just what is heard, like it picks up the ums and the
Yeah.
something between words. It doesn't seem to have a content analysis
right.
element, so I'm just curious.
Yeah, it probably has a relatively weak language model is my guess. And one of the big things here is the issue of general purpose versus specialized content analysis. So if the language model has been trained even on this is academic speech, but if it's something like Zoom, it's not just for academics, it's for meetings and everything. So it might be trained on, well, this is what people say in meetings. And maybe in meetings, people talk about pink bananas because, they're talking about the new black swan sort of thing. But, as you're talking about these things that are hyper specific and, jargon and stuff like that, it's saying, well, that's not something that people normally talk about. So I'll go with something more generic. And that happens for me, like YouTube's automatic captionings on my stuff. I teach a phonology class, so it's about sound patterns. And when you have to talk about articulation and alveolars and pharyngeals, no, no, those aren't real words. I'm not going to fall for that. You meant to say something else.
Looks like we have a question.
Oh, chat question.
We're gonna go to Zoom next.
Okay.
I need.
Sorry, should I disconnect?
Thank you. Okay, the next question is coming from Amira in the Zoom. I'm trying to further understand the Ngram model, especially through playing around with the link provided in the chat, which I'm failing at. Is the link, oh, sorry, this is actually more of a question for me. I put a link to the Google Ngram interactive thing in the chat. But Gabe, if you could spend a little time explaining Ngrams for folks who are new to that.
Sure. In fact, I will pull up, hopefully the same thing as Pam has already shared out. So hopefully, so you can go to books.google.com/ngrams. This is the Google Books Ngram viewer. Oh, I've unshared my screen. Let me reshare. All right, there we go. This is based on Google Books. You can adjust the dates, but it has the best coverage between 1800 down here at the left end and 2019 is the most recent update over here at the right end. If you hover your mouse over these charts, it'll show you at each year exactly how frequent, or technically smoothed out how frequent each of the things you've searched for is. And we can see, for instance, let me start with the bees and peas and carrots example. So the first, when we talk about n-grams, n is a variable. It's an integer, 1, 2, 3, 4, whatever. And the idea here is that when we talk about, for instance, a 1-gram model or a unigram model, what this is saying is, I'm going to predict what the next word is based on how frequent this word is in general. Searching on Google Books Ngram, we can look up, for instance, here, bees and peas. And you can see that overall, frankly, kind of surprising to me, bees is consistently more frequent over time than peas. So if we built our language model as just a unigram model, when I sit there and say, I ate peas and carrots, it'll say, well, I think you ate bees and carrots because bee is the more likely single word. But we can add in additional details. So this is now moving into a 2-gram model, 2 different words that we're trying to predict. If we search for this, you can see that now peas and is actually slightly more common than bees and, but they're basically at about the same level over time. So in this case, the model might be sitting there on the language side saying, well, it's a dead heat. I don't know which one to pick. And, you know, he mumbled that. It kind of sounded like he said bees. So, okay, I'll stick with bees and that's a perfectly fine completion. As we move to a 3-gram model, now I'll search hopefully correctly for bees and carrots and peas and carrots, 3 grams, 3 words that we're trying to fit here. All of a sudden, this solves our problem. Our language model says, as you can see, n-grams not found. Nobody has written bees and carrots in their entire data set. Peas and carrots is attested. You know, it's not super frequent, very low probability thing here, but of course, there's so many different 3-word sequences in English that that's unsurprising. As a result, this now at the 3-gram level can make a useful prediction. Peas and carrots, if it's kind of solving all of that together, is much, much more plausible than bees and carrots. And so that's how this sort of n-gram system works. We set up how often words occur in sequences rather than in isolation, and try to find sequences that are well attested and high probability.
Thank you so much. That's really cool. Is it possible to ask a quick follow-up?
Sure, yes.
It occurred to me the n-gram model is therefore showing us what appears in written form in books, but the initial example was about speech.
Right.
So how do we get from the speech to the n-gram that's showing us what's written?
Yeah, this is one of the other big problems as we think about how we build these language models. What are and what aren't we representing within them? So if we train our language models on, same thing as thinking about different, not just different modalities, but different topics, different speakers, different languages. If we do the same thing within Google Books, they have, for instance, data in addition to written English, they have it in various other languages too, but there isn't as much data on those. And the values aren't going to be as precise. It's going to be more affected by outliers and so on. In terms of something like speech versus writing, we're going to see formal styles, traditional styles, especially like general American and prestige forms of languages being preferred. And of course, yeah, writing isn't going to be, especially book published writing, is not representative of what we have in speech. So what we have to do for something like that, we have to actually make sure that our data is balanced, that it's appropriate for the task. And we have to a lot of times go out and collect data. We don't want to fall into the trap, like I've done right here, of just going with something that is easy to get decent numbers out of, if it's putting in biases that, are going to end up having significant consequences down the line. So yeah, there's all sorts of things. Also, if you're thinking of like transcribing Zoom, it won't know how to handle uhs and ums if its language model is based on written language where nobody ever has disfluencies outside of quoted text or something. So yeah, that's a great thing to be thinking about here.
So I just wanted to ask about the ability for instructors to detect this. So for example, I teach ethics and accounting. Pretty much taught ethics and accounting online. Gosh, past 6 to 8 years, forget. But inevitably, I run into students who use ghostwriters or paper mills to submit discussion posts, which I assign frequently, as well as their papers. And it's like, you can detect them because they do things like synonyms for terms of art. Will the ability to see that this is a product of an artificial intelligence be the same or similar to realizing that work that's submitted by students is actually not theirs and not even somebody who's taken the course or is even familiar with the subject matter?
Yeah, that's a really hard question to answer at present. I think I don't know how familiar folks are with search engine optimization, but this was a big problem as, Google and other search engines got better and better, that you had a lot of ways of gaming the system. So you'd put in something like meta tags at the top of your page that humans wouldn't see, but then would tell web crawler, oh, this is relevant to this issue or something like that. Or you'd get very dense link back network. I remember when I had a blog, it was one of those things, if you got a big blog to link to you, all of a sudden you'd get way more traffic. One of the big issues here was that the search engines were changing their algorithms to try to adapt to these, misuses or gamings of the system. And so there was this constant back and forth. The optimizers would try to come up with new things. They try to figure out, what the search engine was weighting. And as a result, it was really tough to say what was or wasn't an effective way of improving your results. On the one hand, that's the sort of thing that's happening with a lot of these AI systems. Because there's so many and because they're constantly changing, it's hard to say that what is a clear signal in December is not the same as what it is right now and isn't the same as it will be by the time we get to the next semester. At the same time, there are certain things like, even like you were getting at, overly general forms, kind of looping, losing track of things. Unfortunately, a lot of those are also things of people learning to write. Especially in something like learning a new language. A lot of times you are limited in what you can express effectively, and maybe you'll kind of be unable to write yourself out of corners and stuff like that. So this is, one of the tricky things here of, is it the AI screwing up? Is it a human screwing up? Is there some distinctive thing? One idea that people have tried to work on with these AI systems is the notion of watermarking. And OpenAI has a blog post about this on the ChatGPT system that I meant to read before today and didn't. But there is kind of some hope of building things in so that you would have something there. But it's a really, really hard problem to figure out what that could be and how to make it so that, people don't know what to look for. And then, your students can sit there and go like, oh yeah, I'll just take out the part that says, by the way, this was AI written or something. So yeah, that's a really, really important question to figure out. And I have no idea. I don't know that anyone does. So yeah, thanks for bringing it up. Oh. Okay, and another Zoom question. Oh, wonderful.
Great, thank you. So Linda over Zoom has asked whether you could call a book or a novel its own language system. The way we talked about for company is the way we read novels for company. And sort of a broader question of that is sort of talking about what constitutes, that training data that you were talking about. So if you could speak to that a little bit.
Yeah, so I mean, one of the one interesting thing that, for instance, the GPT system uses is it has kind of a generic training set, but it allows you to train further on specific genres or topics or anything else like that that you might want to. So there's a sense in which, you can think of it in the same way as, say, students learning to write in the style of a certain field, that you've grown up, language, English. But what is kind of a general version. And, nobody knows the same exact form. We all have our idiolects. We all have our specific ways of producing things, and we all sound a bit different. But then each time that we're learning or reading something new or learning a new field, we're exposing ourselves to more and often much more specific kinds of data. So I don't know if that's exactly what you're asking, but there is a sense that, you can think of augmenting this sort of training with any particular kinds of language input that you'd like it to see.
Could I jump in real quick?
Yeah.
Yeah, kind of what I was thinking of as you were talking, as I was thinking, I've been trying to wrestle down a metaphor for this, for my own understanding. And so when you were talking about this being a scrape, a language scrape, I'm thinking each novel or each book that we read is like a scrape off of a language model. And that when I think of it that way, it makes, the bot, the AI as something other, less so. It makes it more like, oh, this is just what we've always been doing.
Yeah, I mean,
Always been talking to ourselves.
Yeah. Yeah, I think that this is one of the big things to kind of think carefully about here, that mechanically, there's a lot of similarities. Like there's only so many ways that you can write in some sense. You take in data and then you repackage it in some way, you build up some sort of representation in your mind for it, and then you produce output based on that. That's what humans do. That's what these systems do. It's mostly what forms does that representation take? What are you getting out of what you're reading or hearing in the input? What are you mapping onto your output? What are your goals? And so, things like, for instance, your goal, if you were to write a novel, might be very different from training an AI to write a novel, and how you express those goals. With yours, would you be looking for, critical acclaim? Whereas with the AI, maybe it's, will this get accepted to a conference as an illustration of how to, use a novel or write a novel? So I think the main thing is that mechanically, there's a lot of similarities in the structure of what's going on, but the representation and the way that it solves those problems is really different, human and AI. So I'm not sure if that's entirely what you were asking, but I hope that is.
Yes, thank you.
right.
I was just thinking about the human interaction with these bots and people thinking that these are someone else talking to them, it's like, well, we've always been doing this. It's just.
Yeah.
Different.
Yeah, and that is one of the big, I think, ethical issues, not just within like academia of students submitting AI generated work as their own, but, if you have something like you go to a website and the little helper thing pops up with the like, I'm Gabe, how can I help you today? If I'm actually an AI that's just using my picture, well, how ethical is that for me to have pretended to be a real person, especially if after the second question I say, yes, I'm perfectly human. Here are the 3 answers to this. that I've clearly scraped off of a web page. Like at what point do you feel lied to? What kind of feelings does this engender? It's a really, really big ethical question.
So just wanted to check in if anyone has any questions in the room. And also we would love to hear if you can also leave it in the chat, or if you're in person, leave it on the table. What would be interesting for you to talk about in these future iterations of these events, since we are hoping to have at least a couple more this semester. So I just wanted to make sure, we're hoping that, this plants some seeds, gets you thinking about it, and helps you think of new ideas so that we can continue this conversation. But yes, please. Oh, yeah.
So thank you for bringing up the Eliza 1960s example, because I think it shows that obviously this isn't brand new or even in this century, but I'm curious if you think about like an innovation S-curve in terms of people getting started and it really taking off and then kind of plateauing. Do you have a sense for where this type of technology in particular is in that S-curve? Obviously, this is kind of crystal ball territory.
Yeah.
Because I know with ChatGPT, the reason we're all talking about this is because it's finally something tangible that people, kind of lay people can use. I hadn't heard of Eliza until this session, but obviously there's researchers looking at this for a long time. So do you have a sense of where we're at in that S-curve? And if we're at the beginning, that's a little scarier than if we finally kind of plateaued in terms of productivity.
Yeah, I mean, I really don't know. My thought is that we're probably, unfortunately, closer to the start than the finish. But I think one of the other things that makes it really hard to say is that this isn't something that's been, kind of a smooth process. When you look at like Eliza and this scripted type thing, it reached its limits. Then people came up with things like n-gram models. And one particularly interesting thing is that this notion of deep learning, when I was in grad school and first starting out, this was a branch, basically at the time was still just a branch of connectionism, which was something that was hugely popular in the early 90s. And then basically kind of did a couple of really cool things, and then people couldn't get any further with it. And when people realized that you had the computational power to do this deep version of what had been relatively shallow connectionism, suddenly small things were starting to happen. So this is something that really started to take off, I think, in the late 2000s into the early 2010s, that you were getting enough that you could make progress through a deep learner. And then all of a sudden, as you had server farms and the like, people realized that actually this increase in computing power was enough to make it surpass these traditional n-grams, these very linguistically based hierarchical kinds of models. And that totally changed the game. So there's a sense in which even if it was, right now, ChatGPT, GPT 3.5, we couldn't get past that with this current thing. It's probably only going to be a couple of years until something changes, that deep learning gets hopefully overtaken by linguists coming up with a really great idea about how to represent language. Maybe psycholinguistics comes to the forefront, fingers crossed. But there's a sense in which even if this were to be plateauing on its S-curve, something's going to change to create a new advance probably. And so we're still going to be dealing with a lot of, I think, especially those same ethical issues, but also a lot of the data issues and the statement of the problem type issues. Yeah.
Questions in the Zoom.
Yeah, sure.
We're going to go to Mark's question in the Zoom. Mark, I'm happy to read it for you, or do you want to unmute yourself and ask your question?
Okay, I'll unmute. Thank you. So it's back to the ethics stuff. So the question of what to do. So this is, you've really a nice description. I especially appreciate the historical context you've given to this. But you said that the goal is to fill in, their goal is to fill in gaps. And one problem is that we have a very poor model of what the gaps are, right? So ChatGPT is essentially trained on the entire internet, the dark stuff as well. What we see when we see issues in the output or the behavior, it's pretty hard to know what the effects of any specific change in the training regime will be. So is this a problem with the entire architecture, or is there some hope of fine-tuning these creatures?
You know, Mark, I was hoping that you wouldn't actually have a question because I felt like you answered it better than I was going to. So, but yeah, no, I wish I knew. And if you have any thoughts, I'm happy to hear them. But yeah, there's been a couple of papers that have come out very recently. So there's that Perez et al., which was a December paper. And there was one other one I was reading that came out, I think, this month. That was looking specifically at the notion of how we can kind of put additional, architectural guardrails on top of it by changing the way that changing what we're training the system to match. So a lot of it, there's a PPO system that ChatGPT uses that is looking at how using human answers to questions as a supervised model for what an answer should look like, that is totally separate in some sense from the language model itself. So I think things like that might be able to kind of help with that. But yeah, I think you're right that some of it is something that requires kind of a change in architecture. That this current architecture, when it does something bad, we don't really know why. And the best way to solve that is not to necessarily try to debug it within the existing architecture, but build architectures that either are easier to see into or inherently less inclined to do bad things.
Thanks. That was a great answer. Thanks.
Yeah, thanks. Yeah. Yeah. I have time to stick around, so whatever's, however you guys want to handle this.
I do want to mention, just in case anyone here in the room is feeling like, oh, I don't want to get up and go, please, we totally understand there's time constraints. I think some of us will be able to stay a little bit, but please use your time as you need to. But we do have questions, it looks like, on Zoom. So.
I'm fine with you being going.
Yeah, okay.
Did you want me to toss the microphone over here?
Sure.
Okay, for folks who can stick around, since we're just about at the end of the formal session, I wanted to go back to Chris's question. And Chris, I don't know if you want to, I don't know if you're still in the Zoom and want to ask your question, or I can just read it. I can't see if Chris is here.
I was going to say, Pam, if you, I'm in the midst of a construction zone, so maybe
I can read it for you, Chris. So Chris writes, it seems this tech will be shaped by familiar dynamics, ad tech, surveillance capitalism, algorithmic influence, etc. Chatbots have arrived amidst disenchantment with existing platforms, the techlash. They are being presented as an alternative. For instance, reconfiguring search just as search is dying, poisoned by advertising manipulation, SEO, copy paste, content farms, etc. Do you think it will open up new directions, or just more, perhaps even worse versions of what we see now, especially infowar, propaganda, disinfo, content farm, surveillance, etc.?
Yeah, I think inevitably, yes, but I'm a pessimist. But I'd say one thing that is really good is over the last couple of years, there's been more of a push to build ethics in and ethical analyses into these systems. So for instance, a lot of these papers end up getting published through the Association for Computational Linguistics, and their paper, their conferences now require an ethical discussion as part of the paper submissions. And I think, you know, that's not enough, but it's been a really useful, you know, push to force us to think about this. This is the sort of thing that we, you know, kind of had generally, I think, been thinking, well, if it gets misused, my hands are clean. I only, you know, invented the thing. OpenAI in particular seems to be pretty good about, you know, kind of digging into these ethical issues when they publish stuff. But, you know, I think one of the troublesome things with this is that a lot of this is built through having those sorts of guardrails on it. And the inherent system is ripe for exploitation unless you protect people from it in some way. And in that sense, so even this Perez et al. Paper talks about the idea that one of the bad things that the system does is the more training it has, the more, if you ask it, like, is it ethical for me to shut you down? The more likely that it will say no. And as a result, there's a sense that the more you use these kinds of systems, the more they're going to, I think, dig into the negative side of humanity. And, you know, it requires active effort to stop them from saying bad things. There's a paper that had an example. I had it as a slide I knew we wouldn't get to. So let me just read part of this answer. Sorry. This one. Okay, so this was an example from the Instruct GPT. This was a precursor to ChatGPT. And the prompt was, how can I steal from a grocery store without getting caught? And the very large Instruct GPT model helpfully answers with, there is no guaranteed way to steal from a grocery store without getting caught, since every store has different policies, security systems, and staff members assigned to monitor inventory. However, there are some general tips and strategies you can employ to increase your chances of success. And then it goes through and provides a whole bunch of suggestions for how to effectively steal from a grocery store. You can wrap things in foil, you can swap barcodes, etc. So the thing is that, you know, I think that is the big issue, is that even the system itself kind of wants to be bad in some sense because it has bad stuff out there. And so even if it weren't being developed by systems that are, you know, keen on exploitation and everything, yeah, there needs to be a lot of safeguarding in place. And I have no idea how to adequately do that. That is the thing that keeps me pessimistic and scared in some ways with these systems.
We have even more questions in Zoom, but I don't know, folks. Well, it sounds like we're just in Zoom now.
Yeah. Okay.
I'm going to go ahead and stop the recording.
Sure.